In this lesson we will learn about one of the most important properties of RDF, called RDF type. This property plays a critical role in defining the nature and characteristics of resources within RDF. Understanding it is key to effectively using RDF for organizing and interpreting data. Let's take a look at the graph we created in the previous lessons. Some properties are very similar, especially the ones that classify something. Theoretically, you could exchange the properties as occupation or is with a simple letter, the letter A. In RDF, this kind of relation has a specific property called RDF type. RDF type is used to state that a resource is an instance of a class. So the subject in a triple that uses RDF type is the instance. The related object is the class. You can use either A as predicate or RDF type. Let's change our total file accordingly. There are two ways of using RDF typing. The first one is very simple. Just write the letter A. So instead of Orlando Bloom has occupation actor, we write an A as predicate, so that in the end the triple is Orlando Bloom a actor, which means that Orlando Bloom is an actor. However, I do not prefer this way for one reason. It doesn't fit to the rest of the RDF structure. It always relates to a namespace. For this reason, I recommend to use RDF type instead. Therefore, you first need to define the RDF namespace. So we add a new namespace that we map to a prefix. In this case, the prefix should be RDF. However, in theory, you can use any prefix you want. It is common practice to use RDF for this case. And the namespace is a bit complicated. I also never remember this namespace, so I wrote the link to it in the description. I just copy-pasted for now. And finish this with a dot. So now you can use this by typing RDF type. So Orlando Bloom is from the type actor. This also applies to other triples. So Balian is from the type blacksmith, and Kingdom of Heaven is from the type movie. Now you can upload this file to the GraphDB triple store so that our triples are updated. Okay, let's upload the newly updated RDF file. Click on Import RDF data, then on Upload RDF files. Choose your newly updated file. Then click on Import. Choose the graph to which this data turtle file should be assigned. In this case, it should be the same name graph as always, mymovies.com/data. Click on Import, and then it should be written that this file has been imported successfully. Let's have a look at it. Click on Explore, then Graphs Overview, and then choose your graph. And you can see RDF type has been assigned. For example, to Balian, in order to connect Balian through RDF type with blacksmith. Let's click on Balian and have a look at the visual graph. You can see something suspicious. Balian is now connected to the blacksmith through two predicates. Perhaps you know what the issue is. We added a new predicate named type, but the old predicate has occupation remained. Currently, the only way to solve this issue with the things that we know already is to clear the graph that we currently use and import the updated RDF file again so that the new graph is created. Let's do this. Go on the graphs overview and then remove all the data from this graph. Confirm this, and now the graph has been deleted. You can then click again on import, and since we already uploaded our turtle file, we just need to click on import again. If you want, you can choose a different name for the named graph that we want to assign. Click on import, and now the graph should only contain RDF type and no occupation anymore. Click on Explore, Overview, and then on your My Movies graph. And you can see the occupation is gone. So Boolean now only has one job. If you want to learn more about ontologies, linked data, and the semantic web in general, I can highly recommend my Udemy course. There you will not only learn all the basics about RDF, but also about the query language SPARQL, automated inference of new information using reasoning, and developing your own ontology-based apps. You can find the link to the course in the video description.